Okay, so this is 3.2, the beginning of it. We're not going to get through all of it, but this is the beginning of section 3.2, basic differentiation rules and rates of change. Just to make sure that you're clear on all the notation, we've got f prime of x, the derivative of f with respect to x. This is the same thing as saying y prime, same thing as saying dy dx, but that is the same thing as saying d dx of y. The derivative of y with respect to x can be read either way. And then the derivative of f with respect to x, and the derivative of f of x, so same thing as that. Okay, the derivative of f of x. Okay, so 3.2 day 1. What I wanted to show you, and make sure that you all went into the test knowing, was some basic derivatives. So derivative is your slope, slope is derivative. If your derivative is 5, then that means your function has a constant slope of 5. But if your function is 5, like the function y equals 5, yeah? Then as far as what your slope is, your slope is 0. So the derivative of a constant is 0. Okay? So the derivative of a constant is 0. So that's one of our first ideas. The derivative of a constant function is 0. Using the difference quotient, or using the limit definition of the derivative with x squared, x cubed, and x to the fourth, you can see you expand. We did that. The x squares go away, 1h from each, you're left with 2x plus h, and then the 2x is what's left over whenever the other h goes to 0. Same thing happens with this. It's the term that only has the single h in it, because the non-h's go away, and then the only term with a single h is the one that's left over, because everything else has more h's and they go to 0. So you can see that the derivative of x squared is 2x. The derivative of x cubed is 3x squared. The derivative of x to the fourth is 4x cubed. So you might notice that the power comes down to the front, and then the power is 1 less than what it was before. So that's absolutely true. The derivative of x to the fifth is 5x to the fourth. So the rate of change of a quintic is a quartic. The rate of change of a cubic is a quadratic. And let's see if that makes sense. So say I have x cubed, right? This function is increasing, has a slope of 0, and then increases some more, right? So its derivative should be positive slopes, a 0 slope, and a positive slope, which mimics a quadratic, if you will. Okay? You can tell that it's a very steep slope right here, so it's a very high slope value. Y prime, the derivative is actually has high y values. But then the slopes get shallow, more and more shallow. They're getting closer and closer to 0, and that's what it's mimicking, and then it goes back up that way. Okay, so shallow slopes, positive still, and then increasing and increasing. Okay? The cubic and the quadratic don't share the same shape right here, but that was just the way I was drawing it. Quadratic's wider. Okay, so you see a pattern. The derivative of x squared is 2x, the derivative of x cubed is 3x squared, the derivative of x to the fourth is 4x cubed, 5x to the fourth, 6x to the fifth, so this would be 8x to the seventh. Okay? So that means the derivative of x to the n equals n times x to the n minus 1. So you bring the power to the front and subtract 1 from the power. Okay, so that means I no longer have to do the limit definition of the derivative after this test in order to take the derivative of a polynomial type expression, or even an expression that's not polynomial but has a power of x. Okay, so constant multiple rule, if you're multiplying a function by 3, so if I did the limit definition of the derivative, the 3 would just be hanging out front, so 3 times x plus h quantity squared minus 3 times x squared, so this is f of a plus h minus f of a over h, where a is just x, right? Well, that 3 can be factored out to the front. So I might as well just be dealing with 3 times the derivative of x squared, right? Which is 3 times 2x, or 6x. But that means I might as well just go ahead and you know, like when I bring the power down to the front, just multiply it by the number that's there. So the derivative of 7x to the fifth would be 35x to the fourth. So bring the power down to the front, multiply by what's already there, and then subtract 1 from the power. Okay. So the derivative of this, y prime, would be And if you want to, go ahead and pause your video and try these derivatives yourself. Then you can see if you get the correct answer. 4x cubed plus 12, the derivative of linear is just the constant, right? And always just remember the power, so you move to the front, subtract from the power, that's x to the 0. Okay, just remember it goes down in power 1, so if it's linear it goes to constant, if it's quartic it goes to cubic. So then y prime equals, okay, negative 15x to the 4th plus 24x to the 3rd minus 10 thirds, linear goes to constant, and a constant, the derivative of that is 0, so that's just gone. dh dt, same thing as saying h prime of t, however you want to say it. Bring the 8 down to the front, so that would be 12 t to the 7th minus 60 t to the 4th plus 15 sevenths t squared minus 20, and there we go. So power down to the front, subtract 1 from the power. Power down to the front, subtract 1 from the power. Power down to the front, subtract 1 from the power. And just keep on going. Although if you can just remember, linear goes to constant and constant goes to 0. It makes it faster. Okay, so negative power. So this is a little bit more interesting. This is the same thing as saying x to the negative 2. Well, the derivative still works the same way. We bring the power to the front and we subtract 1 from the power, which means my answer is negative 2 over x cubed. Okay? This one right here, you cannot take the derivative of each term individually, okay? That is not how this works. The derivative is a slope, and this is a rational function. It's no longer a polynomial. But what we can do is we can split it up and say this is the same thing as saying 4x cubed over x minus 32 over x, right? So I know the first one simplifies to 4x squared, and the next one simplifies to 32x and negative 1. So if I try and derive that, not antiderive that, I'm going to bring the power down to the front. Okay, subtract 1 from the power, so 8x. Quadratic becomes linear. Power down to the front, subtract 1 from the power. So final answer for my derivative is 8x plus 32 over x squared. And that is my derivative. Of course, you could do a common denominator, but you don't need to. Okay? So a little bit more interesting when you have radicals. This is the same thing as saying x to the 1/2 power. The derivative of that would be 1/2 x to the, subtract 1 from the power, negative 1/2. Or 1 over 2 square roots of x. We're going to use the derivative of the square root of x so much over this year that it's just one of those things that if you can remember, the derivative of square root is 1 over 2 square roots, because you got 1/2 and then subtract 1 from the power, you get a negative 1/2 power, and it puts in the denominator. Now, I forgot y prime. My second derivative, y double prime, so I just put 2 apostrophes, or primes, I guess. I'm going to use this method, or use this form as opposed to this form, because this form is not in the power form. It's got like x raised to a power. So I'm going to bring the power down the front, negative 1/4, subtract 1 from the power, and I get negative 3/2. So that would be negative 1 over 4 x to the 3/2 power. The third derivative, power down to the front, so that would be a positive 3/8 x to the negative 5/2. So 3 over 8x to the 5/2. And the fourth derivative, now once you get past 3, we start using parentheses with that number, and that means the fourth derivative. And so that would be negative 15/16 x to the negative 7/2. And so negative 15 over 16x to the 7/2. And so if your answer has a negative power, I would expect you to write it back with a positive power. And the same thing goes here. Yeah. So y is equivalent to x to the 4/3. So y prime equals, because we're supposed to find the first 4 derivatives, 4/3 x to the 1/3. Subtract 1 from 4/3. 1 is 3/3, so 4/3 minus 3/3 is 1/3. The second derivative would be 4/9 x to the negative 2/3. So we subtract 3/3 from 1/3, that's negative 2/3. Or 4 over 9 x to the 2/3. The third derivative would be negative 8/27 x to the negative 5/3. So again, subtract 3/3. Or negative 8 over 27 x to the 5/3. And the fourth derivative would be a positive 40 over 81 x to the negative 8/3. So it's just like subtracting 3 over time. 4 minus 3 minus 3 minus 3 minus 3. And so you get 40 over 81x to the 8 thirds. Okay, quite a bit easier than using the limit definition of the derivative. Okay, so final one, find the first two derivatives of the following function. So first, let's rewrite it. Well, go ahead and pause the video and try it yourself, and then you can check your answer with what I've got. So this is x to the 1/4 minus x to the negative 5 thirds plus 6x to the negative third. Okay, first derivative. 1/4 x to the negative 3/4. So subtract 4/4 from 1/4, or 1, and that is negative 3/4. Plus 5 thirds, bring the power down to the front, subtract 1 from the power, so that would be negative 8 thirds. Okay, and then power down to the front, so minus 18x to the negative 4th. Subtract 1 from the power. Or 1 over 4x to the 3/4 plus 5 over 3x to the 8 thirds minus 18 over x to the 4th. And if you want to, you could say 4 times the 4th root of x cubed and 3 times the cubed root of x to the 8th, although that could be simplified, but not going to do that. Alright, second derivative. Negative 3/16 x to the negative 3/4 minus 1, so power down to the front, subtract 1 from the power, so that would be negative 7/4. Power down to the front, so minus 49ths x to the minus 1 is minus 3 thirds, so minus 11 thirds. And then power down to the front, so that's 40 plus 32, so 72. Plus 72x to the subtract 1 from the power, negative 5th. So my final answer for the second derivative is negative 3 over 16 times the 4th root of x to the 7th minus 40 over 9 times the cubed root of x to the 11th plus 72 divided by x to the 5th power. And that is the second derivative. Okay, that's the basics of the power property for derivatives. The derivative constant is 0. The derivative of x raised to any power is, or x to the nth power is n times x to the n minus 1. And this will be a way for you to check your answers. So say on your test I give you something like, find the derivative of, if you're trying to find the derivative of something like 3x squared minus 6x plus 1. Well, at x equals 2. Okay, so I would expect you to use the limit definition of the derivative, but you can check yourself by knowing that f prime is 6x minus 6, plug in 2, and I get 12 minus 6. The answer is f prime at 2 is 6. So we can use that. Now, what I can't use this on is like 1 over 2x plus 7. I can't bring that up as x to the negative power. It's a quantity raised to a negative power. So do not try and use the power property on anything but polynomial expressions or x raised to a power, positive or negative, not a quantity involving x raised to a power. Okay, just a thought.